This video is on how to formulate and solve linear program. Ace Novelty wishes to produce two types of souvenirs, type A and type B. So we have two types of souvenirs. So let's start by making a table because we have many information here. So it's a good idea to organize them. So we have type A and type B souvenirs. Now each type A souvenir will result in a profit of $1. So the objective function is P equals some number times X plus some number or coefficient times Y. I mean coefficient of X, coefficient of Y. This is A, this is B. This is the profit function or the objective function. And we know that in order to write a linear program, we need to write the objective function and some constraints on it. And that formulate the problem or the linear program. So here we have $1 for type A. So $1 for each item. So A is 1 times X, because X are the items of A and Y are the items of type B. Plus, and we have here, and each type B souvenir will result in a profit of $1.20. So this is B. So now we got a profit function or objective function written as 1x plus 1.20y, where A and B are the prices of each unit of each type or each item of each type. Good. So this is the objective function. Now we need some constraints. Now let's continue. The manufacturer type A souvenir requires 2 minutes. Now we are talking about time. 2 minutes, but as I mentioned in the first part, we are talking about prices or costs. That's the profit function or the objective function. But here we are talking about minutes, times. So type A requires 2 minutes on machine 1 and 3 minutes on machine 2. So we have two machines. Let me write them here. Machine 1 and machine 2. So 2 minutes on machine 1 and 3 minutes on machine 2. And type B souvenir requires 1 minute on machine 1 and 3 minutes on machine 2. Then we have some restriction here. There are 3 hours available on machine 1. So on machine 1, we have 3 hours available. So that means when we have 2 minutes of each X and 1 minute of each Y, this should not exceed 3 hours. But since we are talking about minutes here and here hours, we need to unify our units. So instead of dealing with minutes and hours, we need to deal with one unit. Let's use the smaller unit, which is minutes. So 3 hours are 3 times 60, which is 180 minutes. So 2x plus 1y is less than or equal to 180 minutes because we can't work more than 180 minutes on machine 1. And for machine 2, 3 minutes for each X or each item plus 3 minutes for each item of type B should not exceed, we have maximum number of hours to work on machine 2, that is 5 minutes. 5 hours. So 5 times 60, this is equal to 300 minutes. So we only have 300 minutes. So this should be less than or equal to 300 minutes. We can't exceed this number. Now we have constraints. We have x plus y less than or equal 180 and 3x plus 3y less than or equal to 300. Now there's still two other constraints. If you remember the non-negativity constraints, they should be written here. So x cannot be negative and y cannot be negative. So we should write x is greater than or equal to 0 and y is greater than or equal to 0, because x and y denote number of items, and number of items cannot be negative. So we wrote the linear program. We have here the objective function and we have constraints. Now we need to solve this problem. How many souvenirs of each type should ACE make to maximize? We want to maximize the profit. Now we want to maximize profit, so let's graph the region, or the region S, or the feasible, and find the feasible solution. So we have the first inequality is 2x plus y less than or equal to 180, and the second one is 3x plus 3y less than or equal to 300, and we have the other non-negativity constraints: x is greater than or equal to 0 and y is greater than or equal to 0. Now we graph these inequalities, so we convert this into an equation, and then we choose 2 points. So let's choose 0 for x, 0 for y, and find the corresponding values. When x is 0, y is 180. When y is 0, 2x equals 180. That means x equals 90. So the 2 points are 0, 180, and 90, 0. Now let's do the second inequality. We make it an equation, and then we choose some value for x, some value for y. Let's choose 0, 0. When x is 0, we have 3y equals 300. That means y equals 100. And when y equals 0, 3x equals 300. That means x equals 100. So the 2 points are 0, 100, and 100, 0. And those are, it's clear how to deal with those two conditions, non-negativity conditions, in terms of the graph of them. Now we need to graph this region. So this is the x-axis and this is the y-axis. And now let's use the red color for the first inequality. So we have 0, 180. Let's say this is 0, 180, 0 on x and 180 on y. And we have 90, 0. 90, 0, let's say it's here. And then we connect them with a straight line. This is the graph of the line 2x plus y equals 180. Now we need to choose a test value, let's say 0, 0, to see if the solution is above this line or below this line. So we plug this here into the inequality, and we see that 0 plus 0 is less than or equal to 180. That's correct. That means the region that involves the solution should be below this line. Good. Now the second inequality here, for the second inequality we'll use the blue color, and we have 0, 100. Let's say this is 0, 100, and we have 100, 0. This is 100, 0, and then we graph this line, 3x plus 3y equals 300. And then we determine if the region is above or below this blue line. We choose same test point. Let's substitute 0 here and 0 here, still less than or equal to 300. That means the solution will be below this line, the blue line. Good. Now we have other two conditions: x greater than or equal to 0, y is greater than or equal to 0. We know that x is greater than or equal to 0. That means to the right of the y-axis. Y is greater than or equal to 0. That means above the x-axis. Now we have this region determined here. This is the region S. Now let's call it the region S. Now we determine the corners. Since we are using the corner method, or the method of corners, we need to determine those points, those corners. This corner is 0, 0. This is 90, 0, but this is unknown. This is 0, 100, and we knew from previous videos how to find the unknown angle. Actually, we look at the lines that make this angle, the intersection of the two lines, this line and this line. We have 3x plus 3y is equal to 300, and we have 2x plus y equals 180, and then we can solve this. Actually, the first equation can be divided by number 3 to make it easier or simpler. So we can rewrite this system as x plus y equals 100. This is the first equation after dividing by 3. And the second equation, 2x plus y is equal to 180. Now let's if we want to solve it by elimination method, we can subtract, or we can multiply the first equation, for example, by -2. So let's multiply the first equation by -2. We can subtract, and that will give us good easy computations as well. So if we don't want to multiply by some number, we just subtract. We can do that since we have y, positive y here, so that will be 0 when we subtract them. So x minus 2x is -x, y minus y is 0. On the right hand side, 100 minus 180 is -80. So that means -x is -80. So we drop the negative signs, we have x equals 80. So when x equals 80, we need to find y. So we can use the second, let's use the second equation, or the first equation is easier. So this is the first, this is the second. Let's use the first equation. So plug this into equation 2. We have 2x plus y, y is unknown, and x is 80. So 2 times 180 is 2 times 180 is 5 360, and then we solve for y. So subtract 360 from both sides. I think I made some mistake here. So we got x equals 80. Let me redo this part, and let's plug into the first equation. Okay, so 3 times x, it's not 2 times x, that's what confused me. So it's a 3x here, or we just use the first equation here, x plus, I used the second one instead of the first, but let's use the first equation. So in 1 we have x 80 plus y equals 100, and then we subtract 80 from both sides, we get y equals 20. So this point is x equals 80 and y equals 20. So now we got the 4 points. We make a table with the point or the corner and p is x plus 1.2y. Now the points are 0, 0, 90 and 0, 80 and 20, 0 and 100. Now when we plug 0, 0 here, we get 0. When we plug 90 and 0, we get y is 0 and x is 90, we get 90. And 80 and 20, so x is 80 plus 1.2 times y, y is 20. When we compute this, we get 104. Because this is, when we multiply by 20, we get here 24. and then when we add it to 80 we get 104, or you can use the calculator. Now 0, 100, when we plug x equals 0 and y equals 100, we get 120. Now what is the maximum value here? The maximum is 120. This is the maximum, and in the question we want to maximize the profit. So the point that maximizes the profit is x equals 0 and y equals 100. If we produce 100 items of type B and no items of type A, then we get the maximum profit.